Trying to keep our digital lives safe, it can feel like a totally impossible task. We're surrounded by these super complex systems, and it seems like attackers are always looking for a way in. Well, today we're going to dive into this incredible project that makes defending ourselves a whole lot simpler. And get this, it wasn't built by some giant corporation, but by 2 university students. Let's break down how they pulled it off. It really all boils down to this one simple question. Whether you're a massive company or, just one person, attackers are constantly probing, constantly searching for that one weak point. But where exactly are they looking? Well, to really get how they pull it off, it helps to think of any digital system, a website, a server, you name it, as a kind of fortress. And attackers, they're waging a war on 2 fronts at the very same time. So, on one front, you've got what's called the network layer. Just think of these as the literal doors and windows of your fortress. Hackers will go around and check every single one, rattling the knobs to see if anything's unlocked. Then, on the other front, there's the application layer. These are like the guards, the staff, and all the secrets inside the fortress. Here, attackers are trying to trick a guard, or maybe steal a key, or manipulate someone into giving up information they shouldn't. To be safe, you have to defend both. So you can imagine trying to defend 2 fronts at once is incredibly complex. You usually need totally separate tools, maybe even different teams. It's a huge challenge. And that is exactly the problem a new tool called Spider was built to solve. And here it is. This is Spider's landing page. It's a really powerful cybersecurity toolkit that's designed to give you a single, unified defense. So instead of just checking the doors and windows, it also goes inside to interrogate the guards, all from one central spot. But here's the part that I think is really cool. It's who built it. This wasn't cooked up in some Silicon Valley lab. Spider is the work of 2 students, Kumar and Ayush Kumar, from lovely professional university in India. It's just a brilliant example of how innovation can seriously come from anywhere. All right, so how does this thing actually work? Let's start with that first front we talked about, the network layer. This is all about checking the outer walls of that digital fortress for any openings. Okay, so when you jump inside Spider, you find this port and service enumeration tool. An analyst just types in a target, like a website or an IP address, and tells it which ports to check. Then Spider uses this powerful industry-standard engine called Nmap to basically go and knock on every single one of those digital doors.
But wait, what is a port anyway? In our fortress analogy, it's really simple. A port is just a numbered doorway. Computers use literally thousands of these to handle all different kinds of traffic. For example, port 80 is usually for websites, port 22 is for secure logins, and so on. Leaving the wrong door open can be a huge security risk.
So once the scan is done, you get this amazing report on the state of all those doorways. It'll tell you which ports are open, those are the unlocked doors. It'll find the closed ports, the ones that are locked up tight. And it also identifies filtered ports, which are kind of like guarded doors. Something is there, but it's not letting you see if you can get in. And, crucially, it also tries to figure out what service is running behind each open door, which gives you this incredible map of the target's outer defenses. Okay, so that covers the outside of the fortress, right? The walls, the doors. But what about what's going on inside? Let's move to that second front and see how Spider tests the applications and systems running within the walls. And this is where Spider gets really clever. It doesn't just look for open doors. It actively tries to trick the guards. It automatically runs simulations of some of the most common web attacks out there. Things like SQL injection, which is kind of like tricking the castle librarian into giving you the key to the secret archives. Or cross-site scripting, where an attacker could slip a malicious note to another user to steal their info. It also checks for stuff like broken access control, making sure a regular soldier can't just stroll into the king's chambers. These are all critical security risks, a lot of them straight from the famous OWASP Top 10 list. And check this out. This is what the results look like. It's brilliant. When Spider finds a flaw, it doesn't just set off some vague alarm. It documents exactly what it found, like this SQL injection vulnerability here. It gives it a severity rating, high, medium, or low, and shows the exact URL where the flaw exists. This makes it so much easier for a developer to go right in and fix the problem. But the real magic of Spider, its true power, is how it takes all that information from both fronts, the network and the application, and pulls it all together into one single unified view. And this is what you get, the main dashboard. It gives you an immediate, at-a-glance summary of your target's security health. You can see the total number of scans you've run, all the vulnerabilities it's discovered, and a calculated overall risk score. It's pretty much the command center for your whole security assessment. And I gotta say, I love this kind of visualization. The dashboard breaks down every single vulnerability it finds by how severe it is, so you can see in an instant where you need to focus your energy. In this example, 35% of the issues are high severity, and another 5% are critical. Whoa, those are the fires you have to put out first, and this chart makes that priority crystal clear. The whole point here, and this is so crucial, is that the reports aren't just data dumps. They're designed to be actionable. You get real-time progress updates while a scan is running. For every single vulnerability, it gives you evidence snapshots, the exact digital fingerprint of the attack. It even gives you advice on how to fix things, and when you're all done, you can export everything into a professional report to share with your team. I mean, this is already a super impressive tool, right? Especially coming from a student project. But what's really exciting is where they're planning to take it next. So if we take a snapshot of the project right now, the pros are super clear. You get that complete visibility over both fronts, it's pretty fast, and it's an amazing learning tool. Now, of course, it's not perfect. It does rely on another tool, Nmap, being installed, and it's not meant to be a complete replacement for a human expert doing a deep dive. But as a first line of defense, it's incredibly powerful. And get this, the project is absolutely not standing still. The roadmap for what's next is really ambitious. They're looking at bringing in AI to predict vulnerabilities, deploying the whole tool in the cloud so it can scale up, adding even more advanced scanning features, and even building out user roles for big teams. This isn't just a project, it's a platform with a real vision. So in the end, the story of Spider is way more than just about a cool piece of software. It's this powerful reminder that with curiosity and skill, the next generation of innovators can build solutions to some of our most complex digital challenges. Which kind of leaves us with one last question to think about. What other problems are out there just waiting for a fresh perspective to come along and solve?